Hi, this is Stephen Brower from Rock Valley Community College. This is an addendum to Irvine Chapter 12 of the floating point unit. One of the demos I have loaded up into Canvas is a tip demo. And what I'm going to do here is I will have the code on the right-hand side here, and I'll show how things work in terms of memory and interacting with the user. In terms of the code, I'm not going to show the commands for displaying the text on the screen. I'm going to focus just on the floating point numbers. So initially, oops, if I'm focusing in the right place, initially we'll display to the user, the answer to the cost of the meal. And then when this command goes read float, it waits. Actually, we get a blinking cursor here. It waits for the user to type in a number. And then whatever the user types in will get stored onto the top of the stack. If we want to take this and make a copy of it into a variable into memory, we need to do, well, in this case, this is an FST. And what an FST does, it makes a copy of what's on the stack into memory. FSTP is a different command. FSTP will remove the value from the stack. We'll see that as the last statement that we're going to run. Well, then now we'll prompt the user for the tip percent. So the user types in the 0.19. That value goes onto the stack. Again, we want to take the value that's on top of the stack and bring it into memory. So we'll do an FST. The reason why we're leaving them here on the stack is now we can multiply these two together to come up with the tip amount. So now fmul takes the top two items on the stack, multiplies them together, and leaves a single result on the stack. That's the result of the multiplication. So fmul, these two will be removed, and the product of them will be left on the stack. If I want to store that in the memory, then we would use an FST. Now, the reason why I'm leaving it on the stack is I do want to eventually get to the total cost. So I'll make a copy of what's on the stack into memory. So now we're ready to do the, we want to display this tip amount. So there is a write float. And what write float will do is take what's on the stack and display it onto the screen. So it's kind of like, how for write dec and write int, we have to load EAX before doing that. We have to make sure there's a value on the stack before calling write float. Okay, now we want to work on the total cost. Well, to work on the total cost, we need the cost of the meal to add to the tip amount. So we're going to load FLD, the cost of the meal, which is going to take from memory and load on top of the stack the cost of the meal. Well, we just want to add these two together. So adding these two together, we'll do an fadd, and again, we'll take the two items that are on the stack, add them together, and leave a single number, which is the sum of those two numbers on the stack. We do want to display it, so we'll do a write float. But at this point, we don't want it on the stack anymore, and so we're going to do an FSTP. I'm sorry, I forgot about the write float. We'll do an FSTP, and the FSTP will take the value that's on the stack, remove it from the stack, and then put it to memory. So just pointing out the difference, there's an FST here, an FST here, an FSTP here. And the reason why these were FSTs, we wanted to leave the values on the stack for when we did the multiplication. But here at the very end, we want to remove what was on the stack. And yeah, good enough. We're done.